You can use anything.
Yeah, and they don't teach you. You must go teach yourself.
Yo.
Yeah,
It
you
was
must
so
teach
tough.
yourself. After teaching yourself, you must apply it in your project, and it must work.
Hmm. Yo.
Okay, so let's begin. So, Raiders of the Lost Ark, you've been chosen to assist a team of treasure hunters in finding the lost Ark. A treasure map has been reconstructed to find the lost Ark. The problem is that the map has been ripped into pieces. The pieces have been scattered across the mighty utopian jungle. You need to write a simulator game that will teach the treasure hunters how to search these map pieces using the latest utopian drone technology. Okay, so we're using a utopian drone technology to search these map pieces. Okay, so the player is the black circle, and then the trees, the X's, and then the scan range is this large circle, and then the map pieces, the white, wait, large circle. Oh yeah, the map pieces, the white circles, just like this one over here. Charging towers,
Those
charging
rectangle.
towers is the triangle. Empty areas are the empty blocks. Just this empty, basically the empty squares. Those are the empty areas. So you pilot a drone that flies over the utopian forest in the game. So basically, this everything that's here, all the X's and stuff, it's a jungle. So you're gonna treat that as the jungle or the forest, utopian forest. So that'll be the utopian forest. The drone has a specific charge, right? There's a specific charge. Uh, Let me zoom out a bit. So I can't finish this thing. I want to zoom in a bit, but not too much. But this thing doesn't want to allow me to do that. Okay, we're just gonna leave it like this. The drone has a specific charge. The drone can recharge at charging towers, right? And the charging towers are these triangles. Um, uh, that stick out over the forest canopy. Okay. Hidden in the trees are map pieces. So they are hidden in the trees. The drone can scan a specific area and uncover any features hidden underneath the trees. And you see, the key term here is underneath the trees, basically below the trees. So you see this one here, this O here, it makes sense because there's a tree here and it's underneath it. So that means you can only place the map pieces underneath trees. So that means I can have a tree, a map piece here. Uh, okay, you can't have it here because it's going to be above a tree. So you can't have it here. You also can't have it here. It's going to be above. You can't have it here. It's going to be above. Can't have it here because it's going to be next to a tree. It needs to be underneath a tree. So the drone can collect map pieces when a map piece is found. So after scanning, right, it should reveal the map pieces. So if the user chooses the scan option from our options and it scans and then it happens to find a map piece, the drone should collect that map piece. The game ends when the drone has found all the map pieces or the drone's battery runs out. Oh, so yeah, it makes sense. A drone has a battery. It works with batteries. So the game ends when the drones is out of battery and it crashes into, or or it's one of these. So it has found all of the PCs, right? Or it has run out and it crashes into the trees. So
Yeah.
these are all the three conditions that would make the game end. And then I'm gonna have this, use different colors to paint it. You must place the logic of the game in the first namespace. Okay, so let's create the game, right? Okay, so I'm gonna close a lot of tabs here. I hope I can continue where I left off. I hope it doesn't delete. Then I want to close this. Oh, come on. Then I'm gonna close this. Close. And then I'm gonna open Sea Lion. Because I'm not a fan of code blocks. Yeah,
Yeah, sometimes it gives us trouble. Code blocks.
yeah.
And
With this one, it helps you when you're coding. Can yeah, it highlights a lot of things. It can show you the indexes in an array of in your features array. It shows you that this is index 0, index 1, and so forth. It's good. So I'm going to call it computer science 1A track 8 memo
yeah.
2023. And then create. Come on. Okay. Close. Come on. Exit. Okay, so I'm gonna say using namespace standard. This one doesn't put the keyword by default. You need to type it. So that
Every time.
yeah, every time you create a new project. Which is fine because I know what I'm doing. It's fine. I'll definitely remember to put using namespace. So let me create a header file and a source file. So header file, I'm gonna say header file, and then I'm gonna call it forest space. And then it's gonna be like this. And then I'm gonna have a source file. Yeah. Do this. And then I'm gonna have, okay, let me just rename this. And then I'm gonna include that header file, so that I'm gonna do everything here so that I don't forget it. .h, right? And then I'm gonna need to create the namespace. It's namespace, forest space. So you see what I'm doing right now? This is what you should do when you get into the vein. Start including these things, writing the namespace, all of this. And then this namespace, I need to put it here. And then in my main.cpp, I'm going to say hash include forest space.h, right? And then I'm going to say using namespace forest space. Okay, forest space. And then in my header file, before I forget, I'm gonna add the files that I'm gonna need. So I'm gonna need the IO stream for input, for outputting, for using cout, for using string. Yeah, because string it's yeah, string is inside the standard namespace, and integers, everything that I'm gonna need is in the IO string. And I'm gonna need the cstdlib because it has the exit function. And then I'm gonna need the ctime file because it has a lot of things. It has the srand to seed my random function. It has the random function. It also has the time function. I'm gonna need it for that. And then I'm gonna have cassette or cis. Yeah, I know it's but I'll pronounce it as that cassette. But
Cassette.
yeah, it's C asset.
Let's see, I
Yeah,
said.
yeah. I want the asset function. The asset function, remember, it's just a function that makes sure that a certain condition is met. So it's like make sure it has to be like this. Make sure, for example, the number of rows are greater than 0. Make sure that the number of columns are greater than 0. It's just a make sure function. It's a function that makes sure that a certain condition is met by that the program meets a certain condition.
Okay.
Yeah, and then I'm gonna have what's the other one? The SS string for converting to an integer. I'm gonna need the string to convert to integer. To convert a string into an integer. And then that's everything. So you see, after I've done all of this, you know you definitely got some marks, your program is gonna compile, you don't have to worry about a lot of things. In a few seconds, few minutes, you already wrote everything that you're gonna need. The header, the hash includes the namespace, the CPP file, the header file, all of that. So now let's start. Okay, let me see. There's bonus marks, right?
Yeah.
Bonus marks are for record structures, right?
Yeah, I was struct.
Structures and enums. Yeah, we're gonna use that. To be honest, record structures and enums are very good because, for example, you can create a record structure that stores the player's position. So that means I won't need a find player function.
Okay.
Yeah, because it's stored in a record structure. So we're gonna use enums and record structures. So let's do that. So before we start, let's see. So since my game it has more than 2 features, I'm gonna make use of an integer data type. So I'm gonna create a 2-dimensional array of integers, because with integers I have infinite values that I can use to represent my features. But if it was a game that only consists of only 2 features, for example, the empty space and a player, let's say the game only had those 2 features, then I would use a Boolean, because a Boolean, it's either true or false. Then I could use that if I wanted to. You can still use integer even if you only have 2 features, it's still fine. Still fine. I just wanted to explain that part because I saw in one of your memos for a practical, so my student, most of you guys were confused, like, why did they use Boolean here? What's going on?
Yeah, with that
Yeah,
memo.
yeah, with the memo. But yeah, it is fine. They use the Boolean because there's 2 features that you can that were in the game. But since I have more than one, I have trees, I have map pieces, I have charging towers. You see, I have a lot. I have player, I have 1, 2, 3, 4, 5. So I have five characters
Feature.
in my game. So it only makes sense to use an integer. So I'm gonna use an integer, but I'm gonna make use of type definition to define my own type so that I don't have to keep typing this int the pointer int pointer. I don't want to do that. So I'm just gonna give it a meaning, define my own type. So I'm gonna say int pointer. This is going to be 2. I'm gonna call it 2D. That's what I'm gonna call the new data type. It's going to be called 2D array, which makes my code easier to understand and read. And then now we're gonna need enums. We're gonna need enums, right? Enums, remember, enums is basically the same thing as creating constants. It's exactly the same thing. But now with enums, what you're doing is that you're packaging all the constants that represent one thing. For example, I can package constants that are going to represent my status codes. So for example, error in range, error in what, error in this. I can package it inside one enum to say, okay, these constants represent this specific feature in my game. So it's going to represent the status codes in my game. So that's the only difference. But at the end of the day, you're creating constants. So it's the same as me saying int error, let's say int error
Conversion.
Conversion, right? Is equals to -1. It's the same as me saying enum, right? Status code, and then saying error convert, right? But it's stated with okay, it's complaining because I've declared. Let me just change this. They are the same name, so that's why it's complaining. So with the enums, right, by default they start counting from 0 and then they add 1. So if I were to add the next element here, let's say error in argument count, right? Let's say I had this next constant, right? And you can see that the way I've named them, it's an uppercase to show that they are also constants. You also need to make sure you write it in uppercase, in all caps. So it starts from 0, right, and adds 1. So this is going to be equal to 0. And then 0 plus 1 is what? Is 1. So it's going to say 0 plus 1 is 1. And then I add a next one, it's going to say it's 2. I add a next one, it's going to say it's 3. But if you check here, what do I want it to be? -1. So if I wanted to start at a specific point, I can say it's equals to -1, right? And then that means the next one is going to be -1 plus 1, which is just 0. But I also want this one to be a negative value because it only makes sense to represent errors as negative values. Yeah. So I also want this one to be negative. So that means I need to increase this one and make it start, instead of at -1, it should start at -2. So that when it says -2 plus 1, it gives me what? -1. So now this one is also a negative value. If I have another error, I would also have to increase this one to a 3. If I have another one, I increase it by 1 to a 4. So I keep doing that on and on until I have accurate values for each constant. And then we're gonna have okay, so we're gonna have error in converting, right? And then I'm gonna have error in argument count. I'm just gonna call it error arg count. And then I'm also gonna need another error. What's the other error again? You convert to an integer as an error. Error in the argument count. Error in what?
Range.
Error in what? In range? Wait, there was in your tutorials, are they now introducing the range? Like for example, a function called void check range. Are they if they make a function like this that checks the number of rows and columns? Okay.
Yeah.
Okay, so if they've started doing that, so we need to add it here. So error in range, right? So since I have a third constant, I must increase this by 1 so that this is going to be -3, this is going to be -2, this is going to be -1. And then I'm going to have a status code for success to show that it was successful. So success, leave it like that. And then that means this success is going to be what? Equals to what?
0. Yeah.
0. It's going to be equals to 0. So where did you see 0 in our application? There's 0 here. So I give that meaning. I have a placeholder for that. So I'm gonna say return success. I'm gonna change it there because success is equals to what? It has a value of what? 0. Yeah, so it's just a placeholder for 0. it's not necessary to do this, but it gives your program meaning so that if a user, someone who doesn't know code, was to look at your code and see it's like, oh, return, they know that keyword. Return is to get back something. Return success. So it means return a success. So return the return that the program was successful. They can tell by just looking at that. So let's see. I'm gonna have okay. I'm gonna have another enum here for features, right? So I'm gonna call it E features. I'm gonna have an enum for that. So what are the features? We have, let's write it down. So we have the player, right? So we have player is going to be P, right? We're gonna represent the player with integer value 1. Okay, let's start with empty space. Empty space, I'm gonna use dots. It's gonna be represented by the integer value 0. And then player is going to be represented by the character P. It's going to be the value 1. And then trees, they said X, right? I'm just going to use X, the one that's already there. So X is going to be my trees, which is going to be a value of 2. So this is going to be empty space. I'm going to give the constant name on the side. That's what I'm going to call the constant. And then this one is going to be called player. This one's going to be called tree, just tree. Yeah, let's use proper English there. You can't say trees. It's 1x. You can't say trees in plural. You can say tree. Only makes sense to say tree. And then white circle. Yeah, I'm gonna use O's. I'm gonna use an O like this to represent the map pieces, and there's going to be integer value 3. Map piece. Just a map piece. And then charging towers are the ones that are going to be a bit different because there's no triangle on the keyboard. I can't say put a triangle on the keyboard. And I can also make it complicated like this. For example, I mean, technically you can sort of like draw a triangle on the keyboard. You can say this, right? And then you put this character and then you put, okay, let me see. Okay. Yeah, you see, you won't be able to draw a line underneath. Yeah, you can't draw the line, but yeah, you can sort of create something like this. But when you look at this, now it's 2 characters. That's the problem. So I can't do that. So I'm gonna find, what is it called? It's a charging tower, right? So charging tower. I'm just gonna use the hash. It's going to be an integer value of 4, right? And I'm gonna call it tower. Keep things simple. So that's what we have for now. So let's do that, right? And it needs to be in this format. So I'm just gonna cut this and paste it in my code because I want to keep opening both sides, like the notepad and this. Okay, so empty space is 0. So since empty space is 0, I'm gonna start with it here. And I don't need to say is equals to, I don't need to give it a starting point because the starting point of a enum is 0, and that's where I wanted to start counting from. So I'm just gonna leave it like that, and then comma. So what's 1? 1 is the player, so player. And then what's 2 is the tree. And then what's 3? It's the map piece, so map piece. And then what's 4? It's the tower. And then I'm done, right? So now I need to create the one-dimensional array of characters, basically. 1D array of characters. And what characters do I mean? It's this dot, this P, this X, this O, this hash. Those are the characters I'm talking about. and my characters won't change through in the game. Have you ever played a game and all of a sudden, let's say you are racing, right? It's a racing game. You're driving a car in that game. All of a sudden, the features change. Now you're driving the ground, and you're driving the ground on top of the car. Like they've swapped. Like it doesn't happen, right? It's never going to happen. So I'm gonna use const to show that my features won't change. They're gonna remain the same. If I said P, if I said P is the player, that's the player. Or imagine you're playing an adventure game. The character is a person, right? It's a human being. Now you're no longer playing the character. You are playing mountains now. So the mountain is moving like the player. It can never happen in a game. So we're gonna use const to represent that. And it's a array of what it is. So it's char. And then I'm gonna give it a name. Remember, it's uppercase. It's all I use uppercase characters to represent a what? A constant. So that's why I'm gonna call it features instead of just features like this. Yeah. That's the rule in programming. If you're creating a constant, use uppercase. It doesn't matter which language you're using. So remember, arrays by default start counting from 0, right? The same way as an enum start counting from 0. So I don't have, I need to follow the structure that I've declared for my game. At 0 is going to be what? The empty space, which is a dot. So I'm going to put a dot there to represent the empty space. What I like about this IDE, it shows the index for that thing in your array. You see, it's showing it at index 0. It's what value? It's this. Because 0, it represents what? Empty space. That's why I'm doing it like that. And then at index 1, you're gonna have player, which is P. P represents my player. And then at index 3 or 2, index 2, going to be tree. So what did you say tree is? It's X is, right? So X, that's the tree. And then index 3 is going to be map piece, which is O. Right? And then you're gonna have index 4 is going to be the tower, which is a hash. Like that. And I don't need to look at this comment anymore because I have this enum. I know which feature is which. The one at 0 is an empty space. The next one is a player. The next one is a tree. The next one is a map piece. The next one is a tower. I'm consistent with how I'm coding. So now I'm going to have okay, so you've started using this range function, right, to check a range. If you've started you know that you need to create a constant for the rows and columns, right? So you're gonna have const in and say max size. Yeah, it's been a while, so I was thinking of what it's called, and you're gonna just use 100,000. Yeah, I won't put too many zeros, just gonna use 100,000. Okay, we have that, right? And then we're gonna have the record structure. So the way I'm gonna do my record structure, right? I'm gonna start with remember that in code, it starts from top to bottom. So I'm gonna need two structures, right? I'm gonna need a structure for my game, and I'm gonna need a structure for storing the player's coordinates, which is the row and column. So, and the way it's going to be structured, right? I'm gonna have something like this. I'm gonna have a structure, a record structure, right? And this is going to represent my game world, right? It's going to represent my game world, right? And then I'm gonna have everything that's related to my game. So I'm gonna have the rows and then the columns. That's everything that describes the game, right? And then you're gonna have your features. You're gonna have your features, these ones. So I don't think, but let's see. For some weird reason, when I use features like this, it doesn't end well. But yeah, we're just gonna declare that we're gonna have an enum to represent our features, right? We won't use this one. I won't use this one. We won't put it there. We won't put it in here. And then we're gonna need the array, right? A 2D array. Because our game it's a two-dimensional game. So 2D array, and then I'm gonna call this game world,
Mode.
right? So I have so what features represent my game mode? It's the two-dimensional array, the size, which is the rows and columns, and the
And the
features.
features. Okay.
And I'm gonna add extra things. For example, okay, there's more things that I need to add here. So let's look at the first bullet. You always look at the first bullet if you want to see the things that are going to represent your game. So it's size of the environment, right? We did put that, the rows and the columns. The chance of charging towers getting destroyed. So we also need to put that in our record structure. The chance of charging towers getting destroyed. So I need to have int, and then I'm going to have int chance here, right? The chance of charging towers being destroyed. Yeah, charging towers being destroyed. And the number of map pieces. So I'm also going to have int num map pieces, right? And then I'm going to have there's one thing that's missing here. Okay, we are done. So we have everything in the first bullet, right? Because those are other things that represent my game. And I'm going to need to store that so that in case when you scroll down, in case when it comes to movements, right, they say you need to reduce this, the number of pieces, the number of what, at least we have it stored, you see. So that's important. So I have everything that represents my game except for, okay, my brain is kind of zoning out. What else do we need now? We have the array. Oh, the player's location. It's going to help us a lot. So yeah, it's going to help us a lot. So I technically I could say int row, right? For the row. Remember, it's a coordinate. It's like a Cartesian plane. So you have x and y coordinates to locate a specific value. But in our game, we use rows and columns. So you can imagine row is the x value, column is the y value in our Cartesian plane. So that's why I'm saying int row and int column to represent the coordinate or the position or the location of my player.
Oh, you're
But
not saying rows.
you not say, I beg your pardon?
You're not saying int rows.
Yeah, it's row, it's singular, because the specific row and specific column in which the player will be located. But then the problem with this, right? I can't just leave it as int row and int column because I said the record structure is anything that represents my game world. So it's like when I leave it like this, it's like I'm saying I'm going to store a coordinate in my game world. What do you mean by coordinate? Game world is not a feature. You can't leave it like this and say int row, int column. Game world is not a feature. So this is wrong. So what I'm going to do is before this, I'm going to define a separate record structure called I'm going to call it player location. So it stores the player's location, which is what the int row and int column, right? And then now I'm going to create within here, I'm going to remove this row and column. And then you're going to see now it has better meaning. Now I'm going to say store a player's location, right?
Oh.
Store a player's location. And then it's going to be stored. I'm going to create a variable called, I'm just going to call it location. And then now it has better meaning because I'm saying in my game world, I have a player's location. It represents the game world, right? So it's fine. But if I just leave it as just the int row and int column, it's like, okay, what you can't really tell what feature are you storing for. Are you saying remember that in a record structure, you are putting a record structure's name, it's an entity, it's something. You can have, for example, a structure that stores a student's information per student, right? That means I'm gonna have string, okay. I didn't say use namespace standard yet, so I'm gonna say std string, the student's name, right? And then int the student's age. And you see, I only put things that represent this entity. That's what I put to inside of this record structure. Just like in my game world, the structure is game world, right? What represents a game world? It's a two-dimensional array because it's a 2D array. It's a 2D game. So I'm gonna have a two-dimensional array to represent my game. And the rows and columns also represent the game world. And the game world has features. It has a chance of charging towers being destroyed. It has the number of map pieces. It has a player's location. You see, it makes sense. Well, it makes sense once you understand what a record structure's purpose is. A record structure, it's basically sort of like saying, create a structure to represent this something, right? So to represent what this student, to represent what this game world, to represent what anything that you can think of. So we have our record structure, everything is complete. So I'm gonna have this check range, right? It's gonna take in an int value, and then it's gonna take in int is it int? I'm gonna say int lower. I'm gonna call it int lower. Then int upper. So this function, it checks if this value is within this range, starting from this int lower and up until this int up. So that's what it does. And then, okay, I'm just gonna write a comment here, functions. And then if you wanted to be honest, you can, yeah. I'm gonna make it a bit different, my code, right? I'm gonna make it a bit different. Let's use why do I keep saying cassette? Let's use C asset. So I'm not gonna use this. I'm gonna use asset because with asset, remember you're just saying make sure a certain condition is true. So I can say make sure this value is within this range. I can also do that. So there's no need for me to act like I don't know what I'm doing because I can't say I wanna make use of the asset function and then I also define my own function. Like, you get what I'm saying? It logically doesn't make any sense. So I need to show some level of understanding. So I'm gonna use only the asset. And then, okay, I think, okay, we're gonna need the max size. Yeah, because that's going to be our int up or int max. So we have our functions, right? So let's declare our functions. I'm gonna have a function to convert to an int. So int conv to integer. And then it's gonna take in a string. We're just gonna call it str value. Okay, let's just write it in full. Convert to integer. Let's just write it in full. And then I'm gonna need what other function will I need? Let's okay, for now let's have the create world function. Remember that we have record structures now. There's no need for me to say pass in a 2D array, the rows, the columns. No, I don't. There's no need for me to do that. What I need to do is, okay, create world. Okay, we'll fix that on the print world. So here, what I need to take in is the rows, int rows, and int columns, because I'm gonna need that to create the array, to create the game, right? So now the difference is that I don't have to say return a 2D array, right? I mean, I can, but remember I have a record structure. So what I'm going to do is I'm going to say return a game world. So return the record structure. Yeah, because I am creating a game world. So return a game world. Yeah, because the game world, you see it as everything. There's the two-dimensional array that I'm going to need. It has the rows, features, chance, and everything. Yeah. And then I'm going to have a print world function, so void print world, which takes in a game world. And then I'm going to use the prefix rec to show that this is a record structure, so that I remember in my code as I'm coding that, oh, this is a record structure. And by putting the rec, now I know if it is a record structure, now I know that when I want to access something, I need to say rec world dot, then I access that feature or that characteristic in that record structure. And then I'm going to have void delete memory. I'm just going to call it delete memory, which takes in the game world by reference, right? Because I want to make permanent changes. And then say rec world like this. Look at how my code, how simple my code becomes now. You see, it's not going to be that long, taking this, taking that. It's not going to be very long. Okay, there's another thing that I need to take in, the chance and the number of map pieces when I'm creating the world. Remember, we are getting all this information via what? Command line arguments. What am I getting? The size, which is the rows and columns, and the chance, that's the third parameter, and the number of map pieces, which is 4. So when I'm creating the world, I'm going to need four inputs. So I'm going to have int chance here. Then I'm going to have int num map pieces, right? I just forgot to put that there. So that's everything now that we're going to need in our game. I feel like I'm forgetting something. Am I not forgetting anything? Functions. Okay. Yeah, I don't think I'm forgetting anything. So let's just copy this, right? And then go to our implementation file and start implementing. So before I convert to integer, let's create the generate rand function. So int generate random. And mind you that I'm creating it inside the CPP file. I didn't declare it in the header file first because I don't want it. It's not something that's going to be used or that the user needs to know. It's just for the programmers, to make the programmer's life easy. And before I start, now I'm writing code here. I'm actually implementing stuff. So I'm gonna make use of the namespace. So I'm gonna say use the namespace standard. Now it's appropriate to do that in the CPP file because I'm going to make use of strings, cout, this and that. So yeah, I don't want to keep doing this standard colon. I don't want to keep doing that. So it's going to take in int lower, int upper, and then remember we need to find the range first. So int range, and the way we find the range, we say int upper minus int lower, and then we add a 1 so that we get the actual accurate range. Because every time you subtract int lower from int upper, yeah, I don't know, you always have an answer, a range, but it's always missing a 1. So we need to add that 1 so that we get the actual range. And then now I'm going to return the ren function, all right? The ren function, and then modded by the range, basically the range, how many values I want to generate, and then plus to restrict it to start at a specific point, plus a starting point or int lower. So now it's going to generate a random value in the right range. And then you can have, Coach, how do you do those comments again? I tend to forget. I think this will do, yeah. So int lower, this will be the starting point of our range. Yeah, just comment so that when people are looking at your code, it makes sense. The stopping point of our range or of the range, and then return return what? A random integer between what? Int lower and int upper. So that when someone looks at your code, they understand what's going on. Comments are very important. And then here I'm gonna say str value a string from the command line. Let me see. Command line argument. A string from the command line arguments. Yeah, and then return the command line argument converted to an integer. So it's going to return that command line argument, but it's going to be converted to an integer. That's what I'm saying there. Because it is at return. Basically, write a comment to specify what should this function return. And it's going to return a command line argument converted to an integer. That's what it returns. Since I need to return an integer, right? I'm going to create a variable to store that integer. I'm going to call it int value, like this, and then semicolon, and then for now, we're just going to return it so that I don't forget to return the value. And then I'm going to create a string stream, right? Why is it not highlighting? Okay, but it's okay, let's leave it. Okay, yeah, string stream. The string stream, right? It's basically a toolbox or a tool or anything that you can use to form a stream of strings, right? So by stream of strings, right, we mean, for example, you know that bracelet that you that we used to buy when we were young. That is like you buy a string, right? And then they give you buy, or you also buy letters from them, and those letters form up your name, right? And then you add those I think they are squares, right? They are white squares written in black, and then you add them onto that string to form your name, right? And then you tie it on your wrist like this, and then it has your name. You still remember that thing that we used to buy?
Oh yeah. I
You
remember.
remember it? I don't know what it's called. I forgot what it's called. Uh,
You're gonna search it.
yeah, but you remember it, right?
Yeah, I think I know what you're talking about.
Yeah, it's that, like, you usually buy it at the mall or outside the mall. Yeah, it is. You put it on your wrist like this, and you buy those small white squares
Yeah,
with
I know the.
yeah, written in black. Let's say it is the letter S, and then you add the S there, and then it is the letter G. You add the G to form your name. So it's something like that. So you can think of the string stream as what's that thing, that thing that you're adding the letters onto. You know that wool that you're adding. I don't know if
Yeah.
it's really wool, but yeah, that wool that you're adding the letters onto, right? That's a string stream. So we're gonna add that string onto that wool. So in a way, it's sort of like trying to form a name, like you're trying to form your own name. So how do we add that string onto that thing? It's very simple. You just start by writing the string stream, right? That wool that you want to add it to. And then you point to that wool, you put two less than symbols, and then you say, take this string, which is that input, right? Take the string and put it onto that string stream or that wool, right? And then now we want to convert to an integer, right? We have that wool with that string, right? So now we want to take those letters out. So it's like we're taking those letters out now. So how do we do that? We just go back to the string stream and say from the string stream, right? Now look at where in the direction where they're pointing into now. they're pointing onto the right to say that from this transfer, this is an arrow to just transfer. You can view it like that, just transfer. Transfer into what? Int value. Because int value is the variable that's going to store that integer. So transfer into int value. So in this part, right, this line 29, what happens is that it's going to compare. It's going to look at the string stream, which is what's on the left, right? It's going to check, it's going to ask itself this question. What type is the string stream, right? It's going to ask itself that question. And then it now asks, what type is the variable that I am trying to transfer this information into? So remember, it's trying to transfer this string into the integer, into that variable int value, right? So it's going to also ask, what is the data type of int value? And then it's going to compare. So the answer here is going to be string, right? Because it's a string stream, it's a stream of strings. So there's only strings there. And then this side is going to be int, right? Because int value is of type int. So now what I have two different things. On the left-hand side, I have a string, and then on the right-hand side, I have an int. So now it's going to use a built-in function without, you don't have to worry about the details of that function. Just know the procedure. So it's going to use the built-in function inside the string stream and convert the string into an int. So it makes sure that it's of the right type before it puts it in. So this is a simple concept. For example, when you're cooking, right? You always make sure that what you're putting is of the right type, right? You can't take soap and put it in the frying pan to fry meat, right?
No.
Yeah, you can't do that, right? So
Yeah.
it's doing the very same thing. It's making sure that whatever I'm taking here, is it of the right type? Does it belong into this into this container? If it doesn't, convert it before storing it into that container. So it's going to convert the string into an integer. So
Integer.
how is it going to do that? Remember, str value, it's the arguments that we're going to pass in here, right? And
Yeah.
we're going to pass in numbers, but by default, it's going to convert it to text because it's a command line argument. It's by default, it's text. By default, it's text. So what's going to happen right now, right? It's going to take in, let's say the number of rows is 15, right? And it's stored inside str value, right? We're going to take str value 15, we add it onto that wool, right? So that wool is going to have 15. So now when you get to this part, this one is going to be storing 15. So it's going to check this string. Is this string of the right type before I store it inside int value? No, it's not. And how does it fix that? It's going to remove the double quotes. That's all it does. That's literally all it does. It's going to remove the double quotes. And then now it's 15. You see it's 15, right? Then it transfers 15 into int value. So now if you were to say cout int value like this, if you were to do this, int value would have 15. So it's going to output 15. So that's the whole procedure that's happening behind the scenes. But you don't need to know that. All you need to know is the code that's required to convert.
Okay.
But another problem that we can have, right, is that let's say the string in the string stream, right? Remember it was 15, right? That when it's 15, it's correct. And notice the procedure behind converting. It only takes off the double quotes, right? That's all it does. But the question is, what if in between these double quotes I have hello world? So what now?
Oh.
So now by hello world, it means that I came here, right, and I typed hello world.
Hello.
That's what it means as the command line arguments. Instead of a number, instead of typing 15, let's say I type hello. Then what now? What should happen? Let's say it's hello. Let's say it's hello to keep things simple. I typed hello. So if it was to try to convert, what's going to happen? It's just going to remove this, right? Is hello a number?
No.
Is it a number? It's not a number.
No.
So I need to account for such scenarios. So I need to make sure that if it failed to convert, it outputs an error to the user to notify the user that, listen, I couldn't convert this thing into an integer. So let's just check it out. How do you do that? There is a built-in function in cin, right? It says cin.fail. Cin.fail, it means that, remember, cin is to get the input, right, from the user. So cin.fail, it only occurs when it fails to convert. Remember when you run this program, right? And okay, this is hello world, right? I agree, most of the time you get input via the command line, right? Via CMD.
Yeah.
And that input by default is converted to a string because, as you can see, this is a command line. Only text is allowed here. Only text is allowed. So cin, to be honest, this string stream, it works the same way as cout and cin. Look at these arrows. Are they not the same as cout? When you say cout, are they not the same?
They're the same.
They are the same. So even this part, doesn't it look familiar with cin?
Yeah, it does.
It's exactly, so whatever features that cin has and cout has, string stream also has. So cin has this function that states, and okay, let me show you another trick. So with this line of code, when you get input, always think about this process. Cin, what it does, remember cin, it acts the same way as a string stream. Cin, it acts the same way. It takes that string, right? Let's say you entered 15. Remember, it's a string. And then it transfers it into int value. It also asks itself the question, is this thing on the left-hand side the same type as what I'm trying to store there? If it's not, then convert this thing into the right type, into the right data type. So what it's going to do is just going to remove this, the double quotes. So all this time you've been using cin, that's what was happening behind the scenes. It was converting that string into the right type. Let's say you're storing a double, right? DBL value, right? And
Yeah.
they entered 15.9, right?
Mm.
It's going to convert it to a double. How does it convert? It's very simple. It's just going to remove this double quotes and convert to a double before storing it into a variable called DBL value, because DBL value is of type double. So that's what's been happening all this time. So with cin, there's also a mistake. It's something that can occur. That's a problem. So let's say the user entered hello and I'm trying to store hello in a double. So I can use cin.fail to say that it failed to convert. This part failed. So it failed to convert it to the right type. So I can use that very same function with string stream, because what did it say? It works the exact same way as cout and cin. So in place of cin, remember I'm making use of the string stream, right? So in place of cin, I'm just going to say string stream dot fail. You see, it doesn't complain because string stream, it has the same features as cout and cin. So now this part, it means that it failed to convert. So it failed to extract this information in the string stream from the string stream into the int value. It failed to do that process. So what do we do? I say cout cr to output an error, cr. And then you say it failed to convert, and then you specify what it failed to convert, right? What did it fail? It's the input, which is str value. That's that string. And then you say to what? Space to integer, to specify that it failed to convert that string into an integer. And then you start on a new line, and then you exit a program with error in converting. So let's try it out, right? Let's test out the program, right? So let's say I want to get the number of rows, right? Int rows. I call that function convert to integer. I take in that input. Okay, I need to declare the arguments for this function. So it takes in the argument count, basically the number of arguments, comma, that one-dimensional array of strings. And since it's using C, you can in C there wasn't a way to say string like this. So you can't say string like this, one-dimensional array of strings. No. The way you can do it is that you can say, what is a string? A string is basically an array of characters. How do you represent that? Just say character char like this, right?
Mm.
But we if you put these brackets like this, right, it means that you know beforehand what the size is. So remember, we are also taking in the size and taking in the string. So I need to use a pointer so that it doesn't force me to specify the size. So this char pointer, it's equivalent to me saying a string. It's equivalent to that, but it's going to complain because in C, there wasn't a way to represent a string. You could say character pointer, basically an array of characters, which makes sense because it is an array of characters. And then I'm gonna give it a name, right? I'm gonna call it ag. Wait, it's the other way around. Wait, yeah, my brain, the way it works. I'm like, Conche, wait, how do you say ag v like this or ag v comes? In which place do I put ag v?
No, after the pointer.
After the pointer? Oh, I see.
Like
So it doesn't want me to put this. Yeah,
the
I need to put 2 pointers. Yeah, it's C language. Remember C++, right, is a child of C. So you can imagine C is like a parent and it's like a father and a mother. So imagine the father and mother decided to have a child and then the child was born and the child is C++. So with C, it's still old school. The way it creates things is old school. So you need, and yeah, like I said, you can't put square brackets because square brackets means that you know the size, right? So I don't want to have to be forced to specify the size. I'm just gonna say just that string. And then remember, I need to start at index 1 because at index 0, it's always the name, the executable. At index 0, it's always the executable. So index 1 going upward is going to be the the command line arguments that I've typed. And notice in my command line arguments, I've typed in what? Hello. So it's gonna fail to convert. But we handled that error. So let's test it out. Okay, I don't need to see out. Let's test it out because it's going to crash. Boom. You see, it outputs the error. It failed to convert hello to integer. Yeah. So we've handled that scenario, which is perfect. We know that our program works. So let's say I actually enter a correct integer, right? It's not gonna complain. It's gonna convert and give me back that integer. So I'm gonna need to use cout now to see that it actually stored into int rows. So let's test it out. There is 15. So you see, if everything did go well, it's not going to complain, it's not going to moan. I mean, everything went well. So we are done with that, with the convert to integer function. Now we're gonna have the create world. Yeah, this is the challenging part. Yeah, you see when you get to this part, create world, yeah, just know tuziyakhala manje. The number of rows, the number of columns, the chance, they say the chance of what? Of
the towers getting destroyed.
charging towers getting destroyed. So you need to explain what's going on. So this is going to be the number of map pieces. Then it's going to return a game world. Game world, which is basically a structure. So I'm just gonna do that. So since remember the same approach we did here, it was supposed to give me back what an integer, right? This function. So I created an integer and then I returned that integer. So I'm gonna do that same approach. It's expecting what a game world. So I'm gonna create a game world here, game world, and I'm gonna say rec world because it's a record structure. And then I'm gonna return rec world, right? And then now let's resize our let's resize our array, right? Our two-dimensional array. So how do you access information inside of record structure? So you create a variable with the same, and then the data type of that variable is going to be the same name as the name of the record structure. Game world. That's the record structure, right? The name of the record structure. And then I'm gonna use that variable to access information or to access the variables inside of the record structure by using a dot. So after the name record, I'm gonna say dot, and then there we go. And then I'm gonna select the one that I want. I want game mode, the two-dimensional array. And then remember the way we used to allocate, right? So you can imagine, just imagine this is not there, right? Remember we would usually do this and say new int pointer, and then we replace this with that. Remember that's how we allocated, right? So I'm gonna do the exact same thing. But now the only extra feature is that you need to say record dot first. And then new int, remember the two-dimensional array of integer pointers, right? So what I'm going to do is I'm going to say in place of, I'm going to allocate the outermost pointer, the closest dimension, or I can say the first one, yeah, which is that one, the outermost. So you replace, if you want to allocate for a pointer, you replace it with square brackets. So replace it with square brackets. So I want it to start with int rows, right? And then for every single row, I have a specific number of columns. So I want it to follow that structure. So now let me go through every single row. So int row is equals to row that row less than the number of rows. Okay, we need to store before we do all of this, right? Before we do all of this, we need to store everything that we're getting from the user, all of this information. We need to store it in our record structure. So what I'm going to do is I'm going to say, remember this is how I access information in a record structure. I use this variable. So variable record dot int rows, set it to be the int rows that I'm getting from the user. Then record dot int columns, set it to be the number of columns I'm getting from the user, basically the input to this function. And then record dot I called it what? Int chance, right? Set the chance to be that chance, int chance, and then rec world dot int num map pieces is equals to int num map pieces. So now the record structure, it has the values in rows. It's no longer 0 now by default. We've allocated for the record structure. So there's two ways you can go about doing it now. You can start using it and say, for example, less than record dot int rows. You can do that because remember this line of code allocated. So this is not 0. In my record structure, int rows is no longer 0. It's the same value as this one. But if you don't want to go through all that hassle, I mean, you already still have access to this, right? So you don't have to do all of this. You can just say int rows. And then R++ to move on to the next row. And then now I need to allocate for each row the same number of columns. Remember, I need to reference my record structure by using that variable. And then that variable record dot what my two-dimensional array for every single row. So I'm going to pass in, put in square brackets because remember allocated here. The first dimension, it has a size. So it's going to be R and then is equals to new int number of columns. So now I've allocated for all of my rows and columns. So now we're done with allocation. Now we need to set the if you want, there's two ways you can go about initializing the game with features, right? You can do it simultaneously after you've allocated, or you can create a separate for loop. But it's going to be costly. It's going to cost, there's this thing called computational time. So the time it takes to compute your code or to run your code, it's going to use the term expensive. So it's going to be expensive to run your program because you're going to have to do a lot of unnecessary iterations. I mean, you've already gone through the number of rows here. Why do you want to create another for loop, another two set of for loops, doing the very same thing? So we're not going to be redundant. We're going to combine, kill two birds with one stone. So I'm going to come here and say for int row, int column, to go through every single column. Remember, I'm already going through every single row. So every single column less than the number of columns, C++, and then there we go. Then now I can set the game with default features, right? So let's see. How is the world filled? Remember the create world, right? It's only focusing on initialization. That's create world. So everything up until this bullet, it's create world. So let's see. The world is filled in the following order. So let's see. Entities cannot occupy the same position. So this is very important. You can't place a tree in the same location as a player.
Yeah,
So imagine you're in a game when the player is moving, or you can imagine, okay, same location, right? So you can imagine in a game there's a player, right? A human being, sort of like a person in the game, right? It's an adventure game, and that person is carrying a mountain. Will that make any logical sense?
no.
Yeah, and to be honest, no man can do that. Yeah,
No.
yeah. So you need to follow logic. Yeah, so imagine a player is carrying a whole mountain because you've placed features in the same location. We don't want to do that. So let's see. Every square in the world contains trees. Every square, right? So let's do that. Every single square. So that means here, if for every single row and every single column, I'm going to set that to a what? To a tree. I'm going to set that to a tree. So I'm going to say record dot game world for that specific row and column is equals to a what? Tree. Is equals to a tree. So I've done that. I've set everything to a tree. So now, by default, everything's to a tree, right? So we've set everything to a tree here. So now let's check what other features we need to place. So each row in the world has one charging tower located in a random column. So each row, right?
Yeah.
Yeah, to be honest, it's going to confuse you if I combine everything in here.
If you do what?
If I combine everything in here, it's going to confuse you. So let's just write code. Let's just write the way I didn't want you to write it. So I'm going to do another for loop here to go through all the number of rows. Yeah, let's just do it like that because if I start writing it here, it's going to be a problem. But let's just do it because it's going to waste time when you have to click the run button. It's going to take a lot of time. So let's just combine everything in here because that's what you'll be expected to do. So if you listen to the question, right, it said what each row,
In the world area.
yeah, in the world area. Wait. Uh, After this, okay, yeah. So we're gonna do it. We're gonna follow it like this, right? I can't, even though it's each row, this is the for loop, right? And I have to come here and do that, right? I don't want to do that. I want to do it after I've allocated for every single column. So every single thing in my feature has a tree. Afterwards, for every single row, I'm still in the row for loop, right? You see, there's the closing curly braces, there's the opening curly braces. So here, I need to place the what? The charging tower. Charging tower. It needs to every single row, right? I'm only focusing on the rows for loop because they said every single row. If they said every single column, that means I would come here. I would have to come here and set it. Mara, oh, I really didn't want to do this, but will you be able to understand if I place everything inside this for loop, these for loops?
Try.
It's going to be very confusing. It's going to be very, very confusing. But let's just do it. So for every single row, right? So I'm gonna do a rows for loop because I want to go through every single row. Int rows, row plus plus. Every single row, what should happen? I should find a random column, right? So I need to generate a random column. So that means for the column, I need to generate it. So I need to say int c for the column, right? And call my generate random function. Start from 0 to int columns -1. Remember that if you start counting from 0, you stop at the number before int calls. So I need to say -1. I must not forget that. So I have generated the random column, right?
Mm.
So now, before I place the charging tower, right? I need to make sure I'm not placing the charging tower in another in the same location as I've placed the previous charging tower. I know I know at this point I haven't placed any charging tower. I know. But remember that after this is going to go at the start of the for loop, right, and check and then run again, right? So since that's the case, I need to make sure before I place. So I can't just start by placing first. Let's say I say record.gameworld for that row and that random column. I place the tower. I can't just start by placing and then I check after. I've already placed. So I need to, before I place, right, I need to check if I'm not trying to occupy the same location as the previous tower. Remember, it's random. So there's a high chance that wait, let's think about it. Wait. No, I'm wrong. No, it's wrong. It's fine. I can just place it. Remember, it's for every single row. So once I've placed for that row, I move to the next row. So that next row is empty. Yeah. So I don't need to, yeah, let me not overthink it. I don't need to do that. Yeah, I'm used to validating data and things like that. So sometimes you might get too carried away and waste time validating when you shouldn't be validating. Remember, it's unique in each row. So in one row, per row, I'm going to place a tower. So it's fine. It's going to be different for all the rows. And then let's see, we are done with that. Charging towers they say charging towers override trees in that location. So that means even remember by default everything is a tower, right? So they said that it can override. So I don't need to check if in that location it's a tree. If it's a tree, don't place it. No, it needs to be replaced by a tower. So I'm gonna replace that with the tower. So let's check. The command line define map pieces are scattered randomly throughout the world area. They said throughout, but they said, yeah, and there's a lot of logic, a lot of definition here. They said the map pieces can only be placed below trees.
Now they say they're scattered.
Below trees. Okay, it kind of makes sense. Okay, I think it kind of makes sense. Below trees means that underneath this tree, I can put a charging tower. Underneath this tree, I can put a charging tower. Underneath this tree, this one, I can put a charging tower here. So it is fine. You can put charging towers underneath. You can. But let's read it properly. Random, are scattered randomly throughout the world area. Map pieces are initially hidden So initially they're hidden. You don't see them and do not appear. Map pieces cannot be placed on top of each other. On top of each other. So yeah, if you already placed on top of each other on top of charging towers. So if you already placed, if that location is already occupied with the map piece, you don't change, you don't remove that map piece that's already there and put this new map piece. That's what they're saying. You don't place them on top of each other or on, excuse me, or on locations that are already occupied by charging towers.
Mm.
And then they're saying, but it can be hidden below a tree.
True.
So they're saying they're scattered randomly throughout the world area, right? The next thing they're saying they are hidden, right? They do not appear, but can be hidden below a tree. Oh, okay. So yeah, they're just saying they need to be hidden below trees. Or the specific number of map pieces. So we're gonna use that number to place them. So I need to place map pieces, right? And I have more than one. So I need to say int p is less than int num map pieces, right? And then p plus plus, come on, p plus plus. So I'm gonna place the map pieces, right? More than one map piece to place. So let's think about it. How would I place below how would I place below trees? So I need to place in the next column, in the next row, I mean. I need to place in the next in the next row. Because if you look at it, if I try to place it here, the map is, where am I placing it? I'm placing it next to the tree. And that's not what is required. So I need to start from here and then skip one, place it here, and then skip one, place it here. Yeah, wait. If I place it here, it's still above a tree. It's still above a tree, even though it's underneath this tree, but it's above this
It's
tree.
about a tree.
Yes. This logic doesn't play. Hey, what? Let me see. Let's try to read it in a proper way. Let's see. Maybe we missed something. The
Yeah.
command line defined map pieces are scattered randomly throughout the world tree. Or randomly, so just anywhere in the game. But they shouldn't occupy places that are already occupied by charging towers. Map pieces are initially hidden and do not appear. The problem, you see, everything is fine. The problem comes here when they say,
They're
but
hidden.
but
But
can the but just makes everything a bit complicated. Map pieces are initially hidden and do not appear. Map pieces cannot be placed on top of each other or on charging towers, but can be hidden below a tree. So does that mean we should ignore, even though it's still below a tree? Oh yeah, I think we can ignore. Check. You see here, it is below a tree, right? There it is here. It is below a tree. Even though it's next to a tree, but at least it's below a tree.
yeah.
So we're gonna go with that assumption. We're gonna place them randomly in our game world. So what I'm going to do is that I'm gonna start at that first row, right? And then I'm gonna generate, let me see. Okay, for every single row and every single column. Yeah, because they're scattered randomly. They said throughout the world area, throughout. That means everywhere, anywhere in the game world, throughout, right? So I'm gonna need 2 for loops for that, right? So before the way you should structure it, since it's that case, the way you structure it, right? first thing that you're gonna need is the for loop for the rows and columns. That's the first thing. Int rows, row plus plus, right? And then int column, int calls to go to all the number of columns. Then inside within that for loop, then I can now place. But wait, let me think about it. Let's see. For every single anywhere in the world. Oh no. That's fine. That's fine. Yeah. It's fine the way I'm doing it. Yeah. I won't iterate through everything. I'm gonna generate a random row and column. So I'm gonna have int row equals to 0, int column equals to 0, right? And then I'm gonna generate a random row and a random column. So int row is equals to generate random, right? Int 0 and int rows -1. And then int column is equals to generate random 0 int calls -1. -1. There we go. And then now I need to check, right? Remember that the important thing is that you don't place them on top of each other. You don't place them on top of each other because now I'm placing it randomly. I can generate the same row and the same column. That's what they're trying to say. So you can't place them on top of each other. Don't replace what's already there. So I'm going to use an OR condition, just like in logic. Remember in logic, you have this OR. I'm going to use that. So I can either generate a, yeah, and if you check the question, they're giving you a hint. You see, they're saying OR. There's the hint there, OR. So you're going to check if the row and column that I've generated, you're going to check if it points, right? So let's say we do an if statement, right? Remember, I need to reference the record structure. Dot call my array and then pass in the random row and the random column that I've generated and check if that evaluates to a tower. If it's a tower, that means it's already occupied. I'm trying to replace a tower. Or, like they said, or it evaluates to a tree. No, not a tree, a charging tower. Wait. I'm mixing up. A map piece. No, not yeah, not tower. A map piece. Map piece, right? Or a tower. I'm writing exactly the way it's written in the question. They said or because I can either be one of them. You can have in the same location. In the same location, you can have a tower and a map piece. They're in different locations. That's why I'm using or. If I use and, it means that I'm assuming that they don't have different locations. It's in one location for these two features. So if I try to place in, this random column and random row that I've generated points me to a map piece, then something is wrong. I'm trying to occupy a location that's already occupied. Or if this random row and random column points me to a tower, what should happen? I should regenerate because I'm trying to occupy a location that's already occupied. So I need to copy that code for generating. So I need to generate again. But if I use if statement, it's incorrect because this thing can happen more than once, right? So I can't just check once and then leave. What if I check and then it regenerates the same thing? So I need to use a while loop to say while it only stops when a unique row has been generated. So we have that. We've placed our map piece or the tower. We've placed the map piece by checking whether it's occupied, it doesn't occupy another map piece or a tower. So we are done with that. We know it's going to work 100%. So let's see the drone now. What are they saying? The drone starts in a random row. Wait, who's the drone here? Is there a drone? Is there a drone piece here? Okay, there's no drone. There's no drone feature or character there. But they're saying the drone starts in a random row in any of the two columns. On the right-hand side, the drone flies over the trees and can occupy the same location as any other feature in the row. The drone starts at the battery level of 10 units. Wait, is the player the drone? Yeah, the player is the drone.
That's
Yeah.
that's what
They're supposed to specify. They want you to think about it. The player is the drone. Yeah, nah. So
So
basically,
you say
they're
you
talking about
pirate
a player. Yeah. So they're saying a drone starts in a random row. They say in a random row. Oh, yeah, row in any of the last two columns. So the player starts in a random row in any of the last two. So I need to generate a random row and a random column, right? So I'm gonna use int row. This variable that I've already declared here, I'm gonna use that. Don't worry about these rows, the rows that I've generated. It's going to change. It's going to overwrite that information. So generate a random row, right? 0 int rows -1. It's any row, right? But for the column, it's not just any column. It's the last two columns. How do you find the last two columns? It's very simple. The last two columns, right? So let's say we have 0, 1, 2, 3, right? And then these are the rows, right? Remember, it's 0 index, starts at 0, and then the columns are this, right? And then I'm going to have features in between, right? So you're going to have this, and then you have this. Okay, remember that the empty space is just this dots, right? And then you have that, right? So what are the last two columns? These are the last two columns, 2 and 3. So remember, since it starts counting from 0, that means my int columns is, or calls, is equals to 4, right? So how do I get the last two? What is the last column? It's this one, it's column 3. How do I get last column? It's just int calls -1, right? It's just basically 4 - 1. That's how I get the last column. How do I get the column before that? Basically, how do I get 2 if I have 4? I subtract 2. So I'm going to say int columns -2. So I'm going to say before last. This is before the last column. So it has to be any of these columns. So we are looking at these rows, these ones, these coordinates, any of those. The ones that are on this side, we're going to ignore them because they said the last two. So how do we do that? So basically, I need to generate any value between these two, from 2 to 3, right? Basically, from before last to last. That's the range. So let's check. It's going to be before last, right? What is before last? Before last is int calls -2. And then the last column is int calls -1. I just want you to think about it. But yeah, that's how you're going to phrase it. If you wanted to, you can. No one's stopping you. If you wanted to, you could have created a variable called last. And then you say is equals to int calls -1. Then you pass those variables as arguments to your function. You could have done that, but I don't want to waste time declaring and doing all those things. I'm going to just write it as it is. So from that range to that range, right? So between 2 and 3, let's see, based on our formula, let's see if it's going to generate. So I want a random value between 2 and 3, right? Let's find int range. It's going to be 3 - 2, which is just 1, plus 1, which is just 2. So I want to generate two values, which is true because it's either this or this. So it's 2. The range is fine. What's the starting point? Starting point is 2. So if the starting point is 2 and I want to generate 2 values, where's the stopping point? It's going to be 3, which is fine because I want a column between 2 and 3. Basically, column 2 or 3, any of those. So we have this, and we don't have to worry. This is the part that I like. They say it doesn't matter whether that location is already occupied. Remove what's there. You see, they said on the right-hand side of the area. Yeah, we looked at that. But it can fly. Wait, in any of the last 2. Yeah, you see, they didn't mention anything about they didn't mention anything about what is this? Anything about wait, what did I want to say? They didn't mention anything about it occupying another piece. Did you see it here? Do you see it here? Do you see it saying this should occupy this, this should occupy that? Did you see it?
No.
No, it didn't say it. So yeah, we're just gonna go with the assumption that yeah, and you can see here it says it flies over the trees and it can occupy the same location as any other feature. So we can occupy that feature. So I don't have to worry about using a while loop to check, is this already occupied? Is this that? Nah, I don't have to worry about that. So rec world dot game world for that random row and random column is equals to a player. But yeah, I wasn't paying attention to that part. So let's not generalize it because now it becomes confusing. Let's not just say player, let's say drone. Yes, because now it's also kind of confusing me when I just leave it like that. And then this is going to be drone location, the drone's location. And then you're gonna have drone location here because I've renamed it. And then yeah, there's something that we need to add into the okay, let's just say drone. Let me not say drone location. Let's just say drone. There's any information that represents a drone. Because I've realized we're gonna need something about some more information about the drone. Because check here, it says what? Each drone is a battery charge. So I need to declare that. So within this drone structure, I'm gonna have battery charge, right? You see the beauty in making structures because yeah, because if you don't make a structure, if you try to do this, you say int battery change charge, right? If you try to do this, it will never ever in your entire life, in your entire existence in this planet compile. It will never display. I'm gonna show you. I'm gonna show you. You think I also realized that yeah, after during in my session, I was like, Mara, why? Every time I put this, it stops. It stops working, even if it was working. I'm gonna show you. I'll show you what I'm talking about. And they say the drone flies over the trees, and they say it starts as what 10 units. So since it starts as 10 units, I also need to pay attention to what has been said there. So I need to initialize it to 10. So at the beginning here, remember this is where I'm initializing stuff, right? So I need to initialize my drones. How do I reference the drone? I have a location. Yeah, I need to rename that. It's not location. It's the drone information. I'm just gonna call that drone. So dot the drone, right? The drone's what? Battery charge is equals to 10 units when we begin. I know it looks very long, but it's straightforward if you read it. It's a record structure, right? How do I reference it to it? How do I access the variables as a record structure? I create a variable with the same name. The data type of that variable, it is the same as the name of the record structure that I'm trying to access the variables from, right? And then how do I access the variables? I say that variable that I created dot, and then I access the variable. When I access drone, remember that when you access drone is this also what? Record structure. It has its own information. So that I can say after accessing drone, I can also say dot again. and access the battery charge and set it to what, 10, because I said by default it's going to start at 10. So we have placed everything. We are cruising nicely. So let's see. The drone flies over the trees and can, okay, it flies. Yeah. So now we have to go to movements, right? But let's display the game. Let's see. This session is gonna take time. Yeah, so
Yo,
I
it's
think
already 2 hours.
no, I've been waiting for you for 44 minutes. So just subtract 44 minutes from that 2 hours. Yeah,
Yo.
it's not 2 hours as such. It's what? It's 1 hour 30 something or 40.
Oh
Yeah,
yeah, yeah.
1 hour 40. Let's just say 1 hour 40 minutes. It's 1 hour 40 minutes so far. So let's display, right? So with the display, remember with the display, it's very important with display. You always need to clear the screen, right? So you're gonna say system, but remember that there's different operating systems. There's 64-bit and 32-bit. So you're gonna say, this thing's really annoying. I say if, Gonja, you say if what? If and def or if def?
Not, yeah, there it is.
It's if def, ne? Or it's just if?
No,
I think
when the last one.
it's if and def.
Yeah, it's this one.
If Linux. The thing is, they never taught us this thing by the time we were learning. We were doing computer science. I never learned about it. And then, wait, there's gonna be what? And if, you know what? I'm just going to skip this. It's wasting my time because I never learned about it. It's new information to me, even though I understand what it means. But yeah. So me, I'm using 64-bit, right? I'm gonna use CLS. If you're using 32, you'd have to say it clear.
Yeah.
Yeah, and you can check by, I think, let me see. About, just type about your PC, right? It's information about your PC. You see mine, it's 64-bit. It's a 64-bit operating system. So I'm gonna use CLS instead of clear. If you have a 32-bit, you're gonna use clear. So we have that, and then now you're gonna say you're gonna go through each row and each column, because remember that everything in the game is a coordinate. It's like X and Y. Our row is like X, our column is like Y. So I'm gonna need to reference the columns inside of my record structure. How do I reference it? By this variable of which the data type is the same name as the record structure. And I say dot int rows and then r plus plus. And then for int c, c is less than rec world dot int columns and then c plus plus. And then now we need to output, right, to see out. But I'm gonna have a if statement, right? Because I don't want to output anything for I don't want to output anything. I don't want to output any of the, what do they call them? Any of the map. Is it map pieces? The ones that you're not supposed, initially they're hidden.
Yeah, yeah,
Yeah,
yeah.
the map pieces. I don't know how I'm going to output. I don't know how I'm going to do that. What clever way can I do that? Okay, so for now, let me just output all the features. So remember that I'm using an array of integers, right? And the integers that I have, it's from 0 to, these are the integers, right? From 0 to 4. And I have an array that is 0 to 4 features. So I'm gonna use this features array, and then I'm gonna pass in my two-dimensional array inside. So the way you can do this, right, to have less code, you can just say int, let's let's say int index, right? You want to index the features array, right? So I'm going to say recworld dot game world for the specific row and column, right? And then I just pass in the index there. So it's going to output the feature that's equivalent to that integer inside of my array. And then it needs, I want it to be in this format, right? In this 2D format. So after the row, after the column, after the column, I start on a new line. So after I've gone through every single column for that row, I start on a new line. So you see, I've gone through every single column here. It ends here, right? So after this closing curly braces, after it, I output a new line because I've went through, at this point when I reach this curly braces, I've went through all of the columns. So after I've reached the last column, I output an end of line character to start on a new line so that it's in that format. So let's add the command line arguments, right? So I'm gonna have a 15 by 20. I think 15 by 20 should be fine. And then you're gonna have a chance of something occurring. Let's say it's 5%. And then the number of map pieces, let's think. What is it going to be? Number of 5. Let's say 5 of them. And then apply, and then okay. I forgot to do something here. I forgot to store the location of the drone of the player. Remember that we have a record structure to store because I don't want to use that void find player function. I don't want to find the player. I want to keep track of the coordinate. So remember, these are the coordinates, right? So I'm going to store them. So I'm going to go to my record and reference the drone variable, right? Remember, drone it references another record structure called drone that is the row, column, and the battery charge. So I'm going to say dot again int row. So the row for that drone is equal to this row that we've generated, this one. And then I also do the same thing for my column. Dot int col is equals to that int column. Before I forget, yeah, and then that should be everything. We have all the information that we need.
Can you do like comments so I cannot forget?
This line sets the drones. Okay, initial. Okay, sets. Oh, okay, stores the drone's location. So now let's deallocate, right? Let's delete memory. So when you're deleting memory, you need to start by going through. You need to reverse engineer, right? So I'm gonna say go through the rows, right? You need to reverse engineer. So you need to start by the last thing that you've allocated. What's the last thing that you've allocated? It's the columns. So I need to start by deleting that. But those columns, they are for what? For each row. So for each row, that's why I have a for loop that goes through each row. So for each row, I need to delete that. So I'm going to use the delete keyword and delete what record.gameworld. For that row, delete that whole dimension. So this is how you specify delete the dimension. You just leave it empty. Basically, when you leave it empty, it's like emptied out. That's in reference, that's what you mean. But the syntax, even though you write your arrays like this, the syntax, the way it works is that dimension, you don't put it there. You put it after the delete keyword to say that delete this dimension for every single row. And then now I need to delete the rows dimension, right? I need to empty out that dimension for the rows, this one, the rows dimension. But remember, that's not the syntax. You need to add the dimension after the delete keyword, like this. And then you set the game world to point to nothing. So now pointer. And then you're done. You've deleted the memory. There's no memory leakage, so we won't face any issues. I'm not gonna waste time and do the verify if the correct number of arguments. I'm not gonna do that. I'm just gonna start coding. So, but you need to do that to get marks, obviously. So I'm gonna have int columns, then convert to integer. So the next argument after the previous argument, which is argument 2, remember the first argument is going to be the rows, the next one columns, and then the next one is going to be the chance, int chance. Wait, did we use the chance? Something's missing here. Oh, we're gonna, yeah, the charging towers, they didn't talk about. Oh yeah, yeah, okay, we need to use that. Yeah, we need to use the chance. I forgot to use the chance. Oh, wait. There's each individual charging tower being destroyed. Oh yeah, we're gonna use it there. So yeah, it's fine. It's fine. We don't need to place. We don't need to use it when you're placing the towers. So argument, the third one, and then int num map pieces, right? Is equals to convert to integer argument value number 4, and then initialize the game world. I call it the function that initializes the game world. Remember, it returns the game world. And then we're gonna store this inside rec world. And then it's going to say is equals to create world, which takes in all of those parameters in that order. So int rows, int columns, int chance, and int num map pieces. Then I'm gonna print the world taking in a rec world. Simple. You don't have to take in the two-dimensional array, the rows, no, you just take in a rec world. That's what I like about record structures. They simplify your code. So there we go. There's our code. You see, there it is. Where's the player? Okay, there's the drone. Yeah, there's a lot of X's there. Yeah, there's a lot of trees. But yeah, you see, there's our game. I haven't placed the movement, right? The output to say move this, move that. Yeah, we haven't done all of that. So it's there. Remember, these are the map pieces. Are these the map pieces?
No, the map pieces are all. Those are the churching towers. I think. Yeah.
Why are the map pieces not showing? Because they're supposed to show here. I think something's missing in my code. Oh yeah.
No.
I forgot to set them. Yeah. I just left it. I just left it generating. I didn't place them. Yeah, ne. Rec world dot game mode int row int column is equals to a map piece. Yeah, I just left them generating without displaying them. Yeah, there they are. There's the game, our amazing game. There's the map pieces, the drone. So the drone, I think we can use D for drone. We can use that. Let's change that.
The hash
Remember that we had remember that the way we thought it was a player like playing like movements, the normal player, but it's actually a drone. So the way it's going to collect things is going to scan. Yeah. And I forgot to call the delete memory. Delete memory. Yeah, delete memory, that's what it's called. And then, yeah, we have our game. Now we need to find a trick to not display the map pieces, right? So we need to find a trick to not display the map pieces, right?
Oh.
What are they the map pieces? Yeah, the map pieces, the O's. So the way I'm gonna do it, I'm just gonna use a simple if statement. So what I'm going to do, right? I'm going to check the index before displaying, right? I'm gonna say if the index it points to a map piece, right? If it points to a map piece, then output what the features array output the tree. So it's going to be sort of like hidden, and the tree is at index what index 2. So okay, I don't have to worry about the index. I just have to say tree, output the tree, right? So it's going to hide it, and then a space, and then else just output that specific index, right? So let's test it out. There shouldn't be any O's. Yeah, there's no O's. You see, so that's the simplest way you can hide it. It's a trick. You just say, you do an if statement. If I happen to stumble upon a map piece, instead of outputting the map piece, output a tree. In the index, the positions are still stored. We still have the map pieces. They're still there. All I say, just when you're displaying, just don't show them. They're hidden. Yeah, that's the only thing that we did there. So that's the only thing we did. So now we are cruising nicely. Our game is displaying. Now we need to do movements. So let's see the movements. I'm gonna need an enum for movements too. So we're gonna use an enum for movements. So move player, right? The player can move in any direction. They're not playing was even diagonal. Yeah, but it's straightforward. It's not that bad. So what I'm going to do, right? I'm also gonna need a structure for storing the movements. So structure, movement, basically in what direction can the player move in? Player can move up, right? And then the player can move down. Wait, why is it complaining? Oh, a type. Int. I was not specifying the data type. Yeah. Wait, what's going on here? Oh, ish. I'm mixing things here. I want to make an enum, not a record structure. Enum, move down, move up. Yeah, I see now. Move up, move down, move left, and then move to the right, and then move up and move up and what? Move up and left, and then you can move up and right, and then you can move down and left, and then you can move down and right. So these movements, right? It's don't be surprised. It's a simple way to remember how in what direction to move in. It's very easy. You'll be shocked. So it's dot 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 dot, right? And then you're gonna have a P there, dot dot dot. That's the player, right? Okay, let me look for a different location because I want to show the diagonal movements. I'm just gonna have a 4x4 game, right? So I'm gonna place it there, the player. So how would you move here to this? That's diagonal movement, right? How would you move there? So there's two ways you can move. You can move up first and then left, or you can move left and then up. It's the same thing. It's me. I'm just choosing this approach of moving up and left. How would you move to this location?
Move up and then right.
Exactly.
That's right.
How? Yeah, it's right. How would you move here?
You go down and then
And
you
then,
move right. Or
exactly.
you go Or you go to the
Yeah.
left, to the right, and then you go down.
Yeah, but I'm gonna use this approach of going down first. I won't
And
move
then,
left or right first. I'm gonna move down or up first.
okay.
And then how would you move here?
You go down and then left.
Exactly. That's all I'm saying there. Okay, let's talk about the movements, right? The diagonal movements. So how would you move up? Let's start with move up. How would you move up? Mind you, there's lines, right? The straight lines, the horizontal lines is the rows. The vertical lines is the columns. Just keep that in mind. So I'm gonna do this, then one. I'm gonna put the rows, right? Row 3, the way it looks in the array. And then column 0, column 1, column 2, column 3. So how would you move up? How would you move to this location? The way you'd move is you look at the coordinates. Initially, in what location is the player in?
1, 2.
Initially, the player is in what location?
1, 2.
What do you mean by 1, 2? Row or column? Like I want be more specific.
In row 1,
Yeah.
column 2.
Yeah, row
Yes,
1,
I'm
column
looking at the
2.
numbers.
Yeah, that's right. Column 2. Remember what I said, vertically, it's the columns. Horizontally, it's the rows.
Yeah.
So horizontally, in what row is this? It's row 1. Vertically, what column is this? Column 2. So the coordinate of the player is in row 1, column 2. So now I want to move up. I want to go to this coordinate, right? And what's that coordinate? It's row 0, column 2. How would I move up?
Are you asking me?
Yeah. Based on this, I want the answer that I want you to give is I add or I subtract this by this number. That's the answer that I want. How would I move? How would I change this location to be this?
When moving up,
Yeah, when you want to move up.
are you yeah, are you adding or subtracting?
You tell me. What are we doing? What are we doing there?
We are adding.
Incorrect. The way you look at movements, right? You look at the values. 1. How did 1 change to 0? What did I do to 1 in order to get 0?
You subtracted.
Exactly. I subtracted what value? 1.
1.
So
Oh.
you subtract 1 from the row. Subtract 1 from the row. That's how you move up. But how do we denote that in programming? Imagine you have int row. This is int row, right? So you're just going to say is equals to int row minus 1. That's how you can represent it in programming. But as we've been taught, there's a simpler way to abbreviate this. You just say int row minus minus.
Oh.
So yeah, that's how you move up. It's that simple. Because what's the thing that's changing here? It's only the row that's changing. The column remains the same. You see the column, I'm still in the same line, in the same vertical line. I'm still in the same column. The only thing that's changing is the row. I was in this row now. I moved to the row before it. Basically, I subtract 1 to move backwards. So I moved to the row above it. So I just subtract 1 because this is row 0, right? And I'm currently in row 1. How do I get to row 0? I subtract this row by 1. So 1 minus 1 gives me 0. So now I am at row 0. And I'm still on the same column, which is this one. So I moved up. It's that simple. And then you do the very same thing with other movements. So Now, since you know how to move up, down, left, and right, I mean, it's the same approach. The way I'm looking at this, it's either I'm subtracting the row or the column like this, or I'm adding or I'm subtracting. It's still the same thing. So to show you, let me just show you that is the same thing, right? So let's move to the right. How would I move to the right? How would I move to this coordinate, basically? What's this coordinate? You ask yourself, what's the coordinate first, right? For now, we're just writing down. We are planning. You don't need to worry about that coordinate and stuff. So you don't have to worry about that. You just need to worry about the formulas. So for now, we want to find we want to know whether when you're moving up, do you subtract, and what do you subtract, by how many units? We want to know all of those things, right? So moving right, remember the right coordinate is row 1, column 3. So how do I move to the right? How do I move to this coordinate?
So we are at this coordinate now.
Yeah, we're in the same coordinate, row 1, column 2. That's the player, right? He wants to move here.
We are adding
Adding what?
1
To what? To what? I mean to the row or the column.
to the row.
Incorrect.
No, the column.
Yeah. So add 1 to the column,
Column, yeah.
which is basically translates to int col plus plus. That's it. That's how you move. And then if you want to check other ones, it's simple. How would you move there? How would you move there? Straightforward. So yeah, I think we're gonna, let me see. Almost. Yeah, now it's 2 hours, almost. Yeah. So we're just gonna discuss the movements, right? And then do the movements. And then we'll continue maybe later today. If you'll be free later today, we'll finish up this practical.
Okay.
You can't be doing this whole session for like 5 hours or 4 hours. At the end of the day, you're not gonna be getting anything from it to be like, yeah, I understand. When you get there, you can't code. So you can't have a
Lot
very
of
long session.
information.
You can't have a very long session. So let's move down. Okay, let's move left. How would you move left? What is left? What is the coordinate? It's 1, 1. So it's row 1. Okay, I'm just gonna write it like this. Row 1, column 1. So what do I do? How do I move to the left?
Subtract.
Subtract what? You need to be specific. Are you
The
subtracting
column. The column.
from the column? So it's going to be int col minus minus. And then how do you move down? How do I get to this coordinate? This one, this is down, right? How do I get to row 2, column 2? Row,
Add to the row.
column 2. I add to
To the
what?
row.
What do I add?
To the row.
No, what do I add?
You add 1 to the row.
Yeah, add 1 to the row. So it's going to be int row plus plus. You need to try to be clear with the way you are explaining, because if you don't explain properly, you won't also give the computer clear instructions. So you need to try to be more precise with the explanation. So how do I move? Okay, we're done with the simple movements. Now let's look at the ones that require a bit more thinking. So how do I move up and left? So what are the coordinates of up and left? What is up and left? Up and left, it's 0, 1, right? It's in row 0, column 1. Row 0, column 1.
Let's see. Let me see.
There's up and left, it's row 0, column 1. There's this one, column 2, row 1. So this is the initial, right? You don't have to look at the diagram. You don't have to look at this and look at this and see what changed. Look at this and then look at this coordinate. What changed? What must I do?
You subtract the rows and also the column.
So you subtract the row. You need to be more specific. Row. You subtract row by what? By how many
By
units?
one. By one.
Yeah, and then subtract what else?
Column by one.
Subtract column by 1, right? So basically it's this. It's in row minus minus and in col minus minus.
Minus minus.
That's how you move up and left.
Hmm.
So I'm gonna have move up and right. All right, I'm gonna have move up and right. So up and right, let's look at the coordinates. I want to move here, right? That's row 0, column 3. So it's row 0, column 3.
Column 3.
So what should I do in order to, this is initially how it looked. This is how it is now. So what changes should I make?
Subtract row by one. And
Subtract
then
row.
you
Yeah.
add the column by one.
Add column by 1, right? So it's just going to be int row minus minus int col plus plus. And then you're going to have move down. Now we're moving down and left. Let's start with left.
Yeah.
So the coordinate is going to be move down and left. So it's this
Down
one.
and left.
So it's row 2, column 1.
Row 2, column 1.
Row 2, column 1.
Column 1.
So what changes should I make? Initially, it was row 1, column 1. Now it's row 2, column 1. So what changes should I make?
You add the row by 1 and then you subtract the column by 1.
Subtract the column by 1. By 1. So it's going to be int row plus plus int column minus minus. Right? Now we are left with the last movement. So move. So we're gonna move down and right. Down and right. So what is the coordinate for down and right? Down and then right. What's this coordinate? Row 2, column 3. Row 2, column 3. So what changes should I make? Remember the initial it's row 1, column 2. What should I do?
Zoom out so I can see the initial.
Okay, let me write it here. Initially,
it was row 0.
It's row 1, column
row 1.
2. There is row 1, column 2. So there it is. It's right here. So what changes should I make?
You add the row by 1 and then you add the column by 1.
Are you sure?
The rows you add, you add.
You see, you're doubting yourself. You are correct, but you're doubting yourself.
Uncle Gwen, you are saying, am I sure?
Yeah, but I was just testing. You need to be confident in your answers. Yeah.
Yeah.
You add 1 to the row. And you what?
You add to the column by 1.
Add 1 to the column. So it's going to be int row plus plus int column plus plus. So there we go. We have our movement. You see, that's how easy it is to move. So I'm just gonna cut this. Don't save. And then I'm gonna put it here when I call the movement function. So I'm gonna do this and then.
Are we doing this now or?
We can do it in the next session.
Yeah. Let's do it in the next session.
Yeah, but let me add the comments here so that you don't have to think about it. You just look at the formulas that you've derived. So I don't want to create this. I just want to create this comment here. So I won't write all of the comment or everything that I've written here, like the comments and whatnot. Nah, what I'm going to do is I'm just going to say move up, right? And only write the final answer in row minus minus or in row plus plus. I won't write add. I won't write all these explanations. I'm just going to remove this.
Yeah.
Yeah. Just going to leave it to that like this. Then I'm going to have that. Remove this. Then move up and right, up and left. I have that. Yeah, and then I have this. Come on, and then we're gonna have this. Come on, I'm gonna do this. That. And then remove this. So now we have everything that we need to move in any direction. Yeah, so these are the movements. We'll go through them in the next session. Yeah, now you can go take a break, Yana.
No, plus I'm hungry.
Yeah, I'm also hungry. Yeah, go eat.
What time?